think we're live.
So, hey everybody, and welcome to episode number 4 of When Ops Meets Dev. How we doing, Swamy, Robbie? Welcome back. 2-week break again.
Yes, it is getting hot here. I understand it's also getting hot in the UK. Same here in the Mid-Atlantic right now. I'm feeling the heat, but pretty good.
Yeah, absolutely. What's it like with you, Swamy? I think we're getting it's our hottest day over here in the UK. What's it like over with you, Swamy?
Summer is over. We had a couple showers last week and this week. Waiting to see more showers and temperatures to come down. So
Good.
So now guys, we need to heat up with this session 4.
Yeah, no, absolutely. I think we're starting to heat up now. We're starting to get into a few more different options with this this solution now. So I mean, look, I don't know, Swamy, do you want to give a quick recap? Because I know that we had a chat, didn't we, about trying to keep these sessions down to an hour, not to not just overwhelm ourselves, but overwhelm the audience as well, to make sure that we can kind of deliver good messages for each episode. Do you want to give us a quick recap of what we did in episode 3, and maybe then Robbie will jump into where we left off then?
Yep. So here is the markup. As I was mentioning, this is the GitHub where you will find all these repos for this series of sessions. And specifically, if you get into this GitHub, here is the link where you guys can go grab this if you want to play around. And in this previous session, all this previous session and its videos links has been given. Let's see a quick recap. What did we do in the previous session? We have did a deep dive into the Docker commands and the way it has changed from previously we used to say Docker PS. Now we are saying that Docker container PS, because in future they might not support that. And also we did we saw a little bit of configuration. How do we go ahead and add more configuration apart from what is supported by default? And we did a use case scenario, when to use AutoMapper and how to use it. Like some of the fields which are very specific to the domain and not related to the client. There is no point in sending these many bytes over the wire. So we might cut down what has to be sent So that's the scenario which we have shown them. If you see that there are three fields, um, created four fields, created by, created date, created by, modified date, modified by, that we excluded. But we will again do a quick recap on that. But did a pretty good deep dive on that. Now we start. The key scenario is to show why do we need volume mount. That's what we are going to show today.
Yeah.
And
No,
to
absolutely. And
you,
it's
Robbie.
yeah, I don't know, Robbie.
Okay.
Do you want to take over? Are we going to flick over to your desktop? I think, are we?
Yeah, let's switch over. Swamy, I'm gonna let you talk through this a little bit, and I've set up, as you can see. I don't know if you can see on my screen yet, but I've set up
Sure.
just to catch up with where we were in that document to get to the point
Mhm.
where we can run this command. So this is the current command. I imagine I need to first get onto the terminal in the container. What
Right.
am I doing there?
Oh, so here the scenario is like we want to showcase. We have a Docker container, and each of the Docker container, when you create Docker container itself, is the read-only containers, and it will have a very thin writable layer. So when you dismantle the container, you will lose that. So having a persistent storage is one of the ways, and we will do a deep dive into how many ways we can have a persistent storage. But for today, we just want to show a simple use case where we can do a volume mount. So now what Robbie is doing is he's getting into the existing container. He will do that exec into that. Um,
Yep.
yeah,
I've done that,
yeah.
and I've execed, and I'm noticing that I actually, because it's not in the instructions, I've not set up it's in other instructions elsewhere. I think you just were assuming them, that this would be done linearly. But so it's not set up with the database, so we need to set up the database really quick.
Oh yeah, that's pretty cool. It's not at all a problem. So we can go a little bit higher, and wherever you are at this point of time, you can get into that to a Docker exec, and
I'm in. I'm in with the Docker exec. I don't know if you can see your screen at the bottom there. You can see, I think, what's on the live screencast. So I'm going to go ahead and I see it. Actually, I was wrong. You did have instructions for creating the collection
right,
and database coming right
yeah,
afterwards.
yeah, we have already provisioned it. We do an exec into that, and do a Mongo. On which screen you are right now?
I'm on the if you're looking on our screencast view, I think the bottom view shows the actual live screencast for you.
Okay, we are seeing the markdown file. We are not seeing you're in the terminal.
You're seeing the
We're
markdown
not seeing
file.
your session window,
Yeah,
Robbie.
Oh, you're
no,
kidding.
No.
Well,
yeah,
because I shared the whole screen. All right, let me reshare my screen. I thought we had already
yeah.
done this.
Please,
No, we got
yeah,
your
please do a
screen, but
reset.
yeah, we're just not seeing your session window. That's all.
Right.
All right, let me try and reshare.
Okay.
The wonders of modern technology.
Yeah. Do you guys see the Docker, the terminal as well now, or do you just
No,
see?
we just only the markup. We see the markup, the blue color terminal.
Okay, I think we missed this whenever we were preparing, because I thought that I was sharing and you could see my terminal, but apparently that's not true. So Swamy, even though I could show you, I can't put my terminal in the in the browser
No,
so that you can see it. So do you think you could do this? I apologize.
no, that should be fine. Let's go through this real quick, and let's redo that. Let's come back from here. Right. So, guys, let me switch back. And before that, let me speak about this one good extension which I found pretty recently, JFrog X-ray. So, whenever we have any of these images in our local, we can do a scanning, and this guy go and does a scanning of our image for a bunch of vulnerabilities, which is being supported from this JFrog extension. I really liked it very much. And coming back to our story, let's do real quick. I do.
Hey, I was just going to say, I think I got it this time. John, while he's talking, could you verify that? You see my terminal?
Yep, we are able to see that.
Yeah, we can see you now. Yeah.
The black only. Okay.
Do you want to
50% of the world
take back
now.
control? Yeah.
Yeah.
Let's get back on over to you.
All right, let's. I don't mean to interrupt you though. You were going to show the JFrog, or do you want to show that for a couple of minutes and then we'll go on?
Oh yeah, I mean, yeah, this the JFrog is one of the extension which is being provided, and you can have a free version also. This one, the JFrog, and it is pretty good. Um, I mean, anything which is for pretty much like a community service. What Jonny, Robbie, and Swamy we are doing for this, it is pretty much free. We can go and do a scanning of our images before we push this to Docker Hub.
So it says it scans for vulnerabilities. Do you? I
Right.
imagine that therefore it's a security tool. I just don't know. Do you happen to know? Does it scan the container, or is it scanning for like code and securities? It scans the container, I imagine.
It scans the container. It scans the container.
Yeah. Cool.
The JFrog.
All right.
Do you know what kind of output that gives, Swamy? What kind of output it gives when it does the scanning? Is it just a, is it a HTML formatted page or something?
Oh, at this point of time, I mean, I started doing it since couple days, but it always says that it scans and it didn't find any vulnerabilities. So I did created a personal account, and this is what it started. I started using it to go through and scan the local repositories.
That's an interesting thought. You could make like a hello just to verify and see how it works. You could try and find out something that you know it should detect, that it advertises that it detects, and then actually use the vulnerability in your container and see what the output looks like.
Right. It really makes sense to go ahead and see some of this. See here, they are marking it like which items they want to tag it as medium critical or high, and the vulnerability scanning as we used to do. Web vulnerability scanners are there.
So these are the sorts of tools that provide reports that are used to inform DevSecOps, I imagine. It's for security.
Yeah, from the security perspective, we can go and check that what all the items which it finds, like these are the things which it marks as a vulnerabilities. So we need to fix it so that people can go ahead and use our image or the content, our images.
Okay. If we're set, I'm ready to continue with the screen. If you guys.
Oh, please go ahead. Please go ahead.
All right, Johnny. Am I on the screen? I can't see because I got the.
You are.
Screen.
You're there. We can
right.
see you now.
You're there.
So here's that first command. You can see it up here on the entering MongoDB container, and we're just going to go in. You'll notice that my host name and username are about to change. They do. And so this is inside of my container. I can actually run Mongo. And you can see the up and down arrows happen to map well on the terminal, on my terminal at least. That's my experience. So I've got a DB test currently. And I can look at the databases. And do you know what the difference is, Swamy, between show databases and show DBs? It looks like it's the same thing.
It's the same. It's the same.
Okay. Oh yeah. So that just demonstrates the one's the shortcut for the other. I got no collections going currently. We'll fix that someday. And
right.
So now we'll use that. And I believe now if I do, show DBs? Now I should see DBs that are already there. No.
Yep. Oh, until you see once you do
a collection. So I did do that. It's create collection is the one.
Yeah. Next command. You need to execute the next command, and now
I just didn't want to do it because I'd already done it, and I knew I was going to get an error. So.
Okay, I should show that.
Yes. So now that we have it, if we do a show collections, we do see products. We've got products. I don't have data in my products, but I do have products.
So what we can do real quick is just to showcase a couple of things. Go back to your Docker desktop and or just do an inspect on this container. Do a inspect on this container. Exit out of that and do it.
Yeah. So like you mean inspect like a Docker LS?
Yeah, you can. Yeah, inspect Docker inspect space the container ID, and then
Oh, it won't. I wonder if I don't think I named it that way. Oh, it did. Good.
okay, so you can check that what is the volume. So you can see that.
Yeah, I got two different data volumes here. I don't know which one is the one that I want.
Okay, one is for the data, and another one is for config or something. There are two things which gets mapped into that, and if you go into
Yes, I
that,
see. So
yeah,
we want the one that's not for config. It's this one.
right, the data. If you get into that on your file explorer, create a sample.txt and delete the container.
So that doesn't appear to be here. That appears to be the local mount on the container. I have to go
Mount,
back into
exactly.
that.
Yeah,
Okay.
it will be on the mount, local mount.
Punch test file. Oh no. Is data no such file or directory? It's funny because it's all right. So I'm not succeeding here. Was that supposed to run? You said create the file in var lib. Is that's supposed to
Okay,
be written in container, right? So let's look.
right. It will be under var lib.
Right.
Var lib Docker, and which is mounting on this one. I can show it on my screen for a real quick minute.
Okay.
To mind switching to my screen and coming back to yours?
John?
Yeah, do you want to switch over? Yeah.
Yes, sir. Please switch
we
over to my screen for a minute. So if you come back over here, if you go to the volumes, so any of these containers which we create will be backed up on the mount. So one of the mount is one of the place where we will see this mount is this one. Let me switch that for a real quick minute. Come back to Docker. Put it here. And this one. And the Docker. This one, you see? So let's go here. Under the WHL, I go and open this file explorer. I can get into this mount. So you can check this.
Is it worth explaining what we just had to look for then, in case anybody's wondering? So it's just about the fact that the location on your host machine is under that Windows subsystem, that WSL folder locally on your machine. But it's mounted under the var lib in the Docker
But it doesn't seem to do that. That's right, but it doesn't seem to do that in Mac. On the Mac, whenever I went out of the container and did a search for that volume, it's not there. If I go into if you can see on my screen, if I go into the dashboard, I can find that container. It's in like the 0939 is the number and it's in use. And you can see it's attached to shop Mongo that we just ran.
Right.
This is the one. And I can look at the data that's there, but I can't find this folder, the folder that's listed here because of the way that containers are mounted in Docker on the Mac.
Okay, so that will be like we need to go back to the var lib. We'll come back to that in the next episode, uh, Robbie. Well,
Well, it does
will
say a destination is DataDB. I'm
ra-
sorry, I didn't mean to interrupt. I'll let you go back to showing that.
oh, no problem. I want to show this real quick. Johnny, is my screen in share?
You are. You're back.
Okay, thank you, sir. So let me come back over here. Now, what I do is I will just start this shop Mongo. So I just started this shop Mongo, and now once we come back to the volume mount over here, so we should see some extra volumes. I do this refresh, and one of the volume which is there will get mounted onto this one. I can go back to this containers and get into this and do an inspect and come back to this one. So here it says that FAAC and 6025. These are the two things which it is mounting, one for the config DB and one for the database. So we can always go back to this guy and do a refresh. You can see
There it
that
is. There,
uh,
FACC is already there, Swamy.
here.
Yeah.
You can see that. So that's where you see this our collection indexes, everything is there. Okay, so this is one of the things. So let's do a real quick thing. How do you mount it and how do you dismantle that? Okay, let's do a real quick experiment on this one. I will use the shop because the shop Mongo is our primary thing. So I want to use shop Mongo one or something of that kind, so that we'll quickly do one simple experiment uh, to showcase that uh, even if we dismantle and reconnect, so this is how we can do that. So what I'll do is I'll just copy this command and go back to our container over here and okay, this we don't need it. I will directly showcase with the mount. We understand that when we create it, it will have a temporary storage, thin,
Yeah.
readable, but that doesn't help. So this time, what we are doing is we are specifically saying, "Hey, just run this container, use this port, and the name is shop Mongo. I will use shop Mongo one so that it will not trouble us top Mongo one. And what we are telling is technically we are saying that hey, use this var lib Docker volumes and MongoDB persistent store. And one we are mounting it for the database, and one we are mounting it for the config DB. And this is an image. So now we'll see the real fun stuff. Let me come in here and paste that and execute it. So now what happens is it has okay, I need to stop the existing container because that is holding this port. I need to stop this guy.
Or you
Will
just, yeah, or change the port.
oh yeah, oh yeah, I'm sorry. So I'm executing it again. So what it says, okay, the name is already there. So this time I will go and change it to 2. I am changing it to 2. So now you can see that it has created the shop Mongo 2. So we can come back to this containers over here and we'll see that shop Mongo 2, this we don't need it. I will delete that so that we have less things to deal with. So we have created the shop Mongo 2. So when you go back to the shop Mongo 2 and do an inspect, now it clearly shows that it has done a volume mount. And it has done a volume mount MongoDB config store and MongoDB persistent store. So I can come back to that mount on my hard drive. Okay, so if I come back to the volumes and I see this, the persistent store as well as the config store, just for the sake of simplicity, I'm saying that hello Robbie.txt. I'll just create a small file, just to prove the theory that, hello, I'm creating. And inside the hello Robbie, I'm saying, hello Jonny. Okay. So just to be in sync. So now what I'm doing is I'm coming back to this guy. And what I'm telling is I go back to this containers and locate this guy, shop Mongo, and I'm doing a stop. So this is stopping it. And what I'm doing is I'm deleting this. Now I dismantle the container. Now the container is gone. Okay. So now if I do search for that container, shop Mongo or something, I have only this shop Mongo. There is nothing called shop Mongo 1 or shop Mongo 2. So now what I can do is I say that shop Robbie, Jonny, Swamy. Okay. So I'm telling that shop Robbie, Jonny, Swamy, Mongo. So it's not, you don't need to have the same image name, sorry, container name, but you can have anything. But right now, if you go and create another uh, container, but what we are doing is we are mounting to the same volume. So now what happens is we can come back over here real quick and see this piece. We can come back and see this piece. It has mounted the same volume, external volume, the persistence volume. You see that? So now, even if I go back, even if I go back to the volumes over here, even if I go back to the volumes over here, so that guy should show. It's taking a little bit of time on this volumes. We will see that here. Docker volume ls. Okay. You see this, these are the volumes which is already there, and the volume which we created is this volumes. Okay, these are the couple of volumes which we created, and you see that whatever the file which I have created, that is still there. The only thing is this volume is external, it's a persistent storage. When we create a container, we can map that container, or we can tell this container to go and use the same volume mount, which is an external storage or persistent storage. So there are a lot of things in this. We can have the NFS, and we can have Azure file share. A lot of things are there that will be derailing the existing session. So
If I
I'm
can
going
just
to.
comment on that really quickly, a clear use case for this is whenever you want to have a you want to have a database as a service, you want to have your MongoDB be something that can serve the data and maybe even load up and run across regions or something. You would want to be able to work from a single location of data, like a single source of truth, and have the database resource just be responsible for serving, for interfacing that data, right? So that you could have the storage in Azure Blob Storage or something like that, mounted separately. From you could separate out your concerns that way.
Yeah, one more use case is like you want to share a storage like this. One of the use cases, there are two different microservices, but they want to use the same file share. That means let's assume that one of the microservices which is downloading the usage of mobile data, like how many of the users are using this a particular service, so that is incoming. So microservice A is getting the content of the mobile data usage from 1,000 users and putting it into a CSV or Excel file and dropping into the file location. And there is another microservice which takes this, processes it in an engine, and gives the result back saying that, okay, based on today's usage, tomorrow you need to generate these many bytes or these many new songs or stories or movies, like forecasting what could be the usage tomorrow. And that again drops it to the same file location. Like you want to share a volume or a location, two different microservices. Am I making
Yeah,
sense?
no, that's right. That's absolutely correct. I mean, at
Yeah,
that point, it's blob storage, so anybody can access it and they can consume it however they're prepared to consume it. Um, I was just thinking, since we're tightly coupling this with the Mongo right now with MongoDB, that's going to be, the one of the benefits, the immediate benefits for us is that we can have the data separate from the database, so we can bring up a new resource for our database. We can say, okay, let's start a resource. So we start a MongoDB resource, and we don't have to start fresh. We don't have to like pre-populate it from the code. We can actually have populated
right.
data.
Exactly. That's cool. So let's come back to the next section of what we are going to do this. The Docker Compose. Let me switch back to my screen. Now here, let's do one thing. Uh, let's execute the same thing, which is nothing new. Which we want to show that the use case. Why do we need this Docker Compose? In the meanwhile, let me go and check. Do I have my cluster ready? Yeah, the cluster is ready. That's pretty cool. So let's execute this in a couple of things, and then we'll build up a story that why do we need the Docker Compose. Okay. So at this point of time, if you see, we have we have this different containers. So let me come back to this container and dismantle the shop Mongo, whatever we created. I'll just dismantle it and I'll go ahead and delete that. I don't need it, so I'm deleting it. So now coming back to this one, shop Mongo. I just start this shop Mongo. So this is one of the container in our Docker host. Okay, and at the same time, you see that our API should also be running as one of the another container. If you see this, okay, this is not container, this is executing as part of the kestrel. You can see this is a separate box. Now the communication is from a kestrel which is on the host machine and going and talking to the MongoDB which is inside the Docker container. So we are able to go and get the content. So this understand the scenarios. We are showing how we are progressing. So now what is happening is the MongoDB is inside the Docker container. We understand this. The MongoDB is inside the Docker container, and the API which is executing is on the host machine. So now the host machine is talking to the Docker container through the local host, because we did the port mapping. The port mapping in the sense, once we go to this one, see the port mapping when you do an inspect. So here you see this port mapping. It says that any IP, if someone is coming on 2701, that means it's going to allow, because the way we created it, the host port versus the container port. When someone hits 27017 on the host, it's going to route it to 27017 on the container. So that's the first scenario. So now I'll stop this. Let me stop this. Now what is happening is, here we discussed the API is inside on the host, and the MongoDB is inside the Docker container. Now let me switch back to the Docker container. Now we should be little bit careful. It's not that big of a deal, but we just need to be little bit careful. Let me show that to you guys before I jump into that piece. Yeah, let's come back to this containers, and I really like the way these IDs are nowadays. You can see this. Let's go back to the MongoDB container, which is somewhere over here. So this is MongoDB container, and let me expand this a little bit, and we can come to the details and scroll to the bottom. The same thing we can get it through this uh, through the command, which we already showed it in the previous episode. So the IP address of this Docker container is 172.17.2.0.2, but our calls will fail now. Why it will fail, I'll show you in a moment. Because when we are hitting this to the Docker container. Let's go to the properties. And inside this launch settings, inside this launch setting, inside this launch settings, I will come back to this launch settings and see this. When it is a Docker profile, we are saying that uh, go and access the MongoDB on 172.17.0.3. That will fail because here, if you come back to this containers, you see that the MongoDB is one of the container in the Docker, and also the API is also one of the container. Now we have two containers inside the Docker. Now there is a container to container communication, and it is talking over the IP. So now what we need to do is we'll need to quickly come back to this one and change this from 0.3 to 0.2. Because how do you know that? So when you go to the MongoDB container, you can execute the command also, which we have showcased in the previous episode. You can use that. Also, you can see this now, the IP address which has been allocated to this container, the shop Mongo container, is 0.2. So now
To
if I, yeah, Robbie.
nothing. I was just noticing it's 0.2. It's not 0.3.
Yes, correct. Because we just created a couple of other containers before enabling this container. So maybe those containers would have got those IP addresses. And again, this is a bigger discussion. How does this IPs gets allocated? We will discuss in length once we go into the Kubernetes world. Now you see this, you're getting a different port. Now you can see that we have these two containers. Right now we have two containers within the Docker environment. I want to visually show that. Come back over here. Now you see that you have the shop Mongo as well as shop Mongo is that, and another one is API. So the products API. Now both are there within the containers. Now the container to container communication happens through the IP address. Now if I go ahead and do this, uh, go ahead and do, and I'm getting it. Now is the real case. Why do you need Docker Compose file? Now imagine we have two containers. Even with these two containers, we are not sure what will be the IP address of the database, and what will how should the API should communicate with this database. We are not sure because anytime this IP address changes. So again, we need to come and do this. So this is with only two of these containers. That means the entire life cycle of these two containers. How do we need to maintain? We can write PowerShell or shell scripts or different kind of mechanisms. We can use it to handle it, but these kind of small issues might pop up. Not only these, and bigger things might come. So the other way to handle is, let me go back and stop these two containers. That's where,
So if
yeah.
you could just pause for a second, what you're trying to do to handle it is you're going to specify, I imagine you're going to specify the IP address that it should request.
uh, when we are dealing with the when we are dealing with Docker Compose, that's what you're asking about.
Yeah.
Oh yeah. So what will happen is when we do with the Docker Compose. Let's see the Docker Compose file for a couple minutes, and we will discuss. So when we come to this Docker Compose file. So in this Docker Compose file, what we are saying is, hey, here is my environment. On line number 4, we are saying that I should have something known as products DB, and that is the name of the container. And I'm saying in line number 7, I'm saying that I will have a products API. Now these two services has been bundled, and it is being taken care by the Docker Compose. And also we are saying that the volumes is Docker Mongo. And the other important things is all the nitty-gritties we will write it in Docker Compose override file. So I'm saying that, hey, one of the services is products DB, and the container name is this one, and these are the ports which it should be, like a host port and the container port. What is the volume? Mongo data. And here we are saying that I should have a products API. This is the container name, and some of the environment variables which I have to inject it. One of the things is Mongo settings connection string, which we can real quickly compare with the way we injected this in the profile. Whenever it is Docker, we are saying that go and access this MongoDB on this particular IP. But when you compare that particular line, let's copy this and do a real comparison there. When you compare that line with how are we accessing here, so we are saying that the same MongoDB settings, but we are saying that don't access it through any IP. We are accessing through the containers. Now, the Docker Compose is taking the responsibility of all the containers which it is having within its services. Now, it takes the lifecycle management of these two containers instead of going through the IP address and all those complex things. Now, we are saying that, hey, go and access this particular container, the MongoDB container on line number 5. We said the container name. I just use this one. So now it knows that the Docker Compose knows this lifecycle. And also another good thing is if we either use the API on host and the Docker MongoDB inside the Docker container, whether the Docker container is ready or not, the API will fire up, it starts, and when it tries to reach the MongoDB, that's when it will blow off, saying that I'm unable to reach. You don't know why it is failing. That's scenario one. Scenario two is imagine where you have the API container as well as the MongoDB Docker container. You are having two different containers and you're executing the API through container. Now the container to container communication should happen. So here again, couple of scenarios. Whether the MongoDB container is up or running, this container doesn't know. And this container again need to go and get the IP address to talk to it. Now we are clearly saying in the line number 19 is do not start this API until the product DB is up and running.
So is
Okay?
Docker talking through the like the way that is happening? To me, that looks like you've got container name, and container name is being designated in a DNS service. So there's got to be something that's actually there's going to be some way that it knows the products DB and that string that you're setting, because that's an
Yes.
environment variable string, right? You're not actually you're not handing it something that it knows to expect. The Docker doesn't know anything about MongoDB settings, right? So for that to work, that has to exist outside of MongoDB. There has to be a host name relative to the Docker container or the Docker compose that you're doing there that maps product DB to whatever the actual IP address is.
Oh, this Docker Compose guy will marry those two containers. We'll see that. Like Docker Compose. Now see this, the Docker Compose tool, which defines running multi-container Docker applications. So that means this guy is going to marry all the containers, or it goes through that life cycle. We'll see that visually in a minute. Now that we are able to see that API, it's running in 8001. Let's do a real quick execute, and we got the content. Now keeping that aside, once we come back over here, and let's do the probe. Now you see this, our shop Mongo container is not enabled, and let's come back to the API. Okay, so the products API is there, but that doesn't matter. We can go and stop it if needed, or I'll leave it as it is. Now you see this. Now the Docker Compose guy is having this as well as the MongoDB. So it has got these two things bundled up. Let me close this and let me come back here. You see this? The Docker Compose. It's like a parent or the layer. It's there, and it has got all these containers which we have defined in the YAML template. So it knows that. Now it knows this name. The container name is products DB. So when we gave the instructions here we are passing it as part of the environment variables. When we said MongoDB and products DB, so now the Docker Compose knows it because this is the child of this Docker Compose. Docker-Compose. It knows that, okay, products DB, or how should I communicate between these two? Because it has married these multiple containers which it is handling. Does it make sense, Robbie?
So yeah, I think that you said that you are describing the same thing, that those two are in fact mapped. I'm just pointing out that that variable being set is a string, right? So Docker doesn't know that that string is going to be read as a host name elsewhere. So it's not like interpolating. It's not looking for the container name in other settings and replacing them. That would be dangerous, right? Instead, what
Right.
it's doing is it's acting as an interim host. So whenever you go to connect by IP address, you connect by IP address within your container. Within the what's the outer container in a compose called?
Right. Here, if you see that,
Yeah,
line
there.
number 5, we set the container name. The same container name should be here.
Right. And the
Right.
way a way to do that in networking would be to use a domain name service. So you would do a search for product DB, which would transpose to productdb.local, and productdb.local must be being set in your Docker Compose, and the creation of that container or set of containers, however that works, um, it must be setting those values so that those hosts, maybe not in a DNS. Another way you could do it is in a host file, but something like that.
Okay, so the FQDN translation into this one is it, Robbie?
What was
The
that?
fully qualified domain name mapping to a particular
There's
IP.
got to be a domain name mapping in some way, either in a host file or a domain name
Yeah.
service. The reason that I'm saying that is because you're not setting a variable that is a known system variable. You're setting a string, you know. And also,
Uh,
the protocol is MongoDB. And MongoDB is not a known protocol either. So there's just no reason. It's not reasonable to expect that Docker would know that that product's DB is a host. It has to do that translation using the system resources that are available. So like the host file or a domain name service.
Right. Here in our scenario where the Docker Compose is creating this one. So if we go and look into this, if we go and look into this at the top, so what will happen is these guys, they will be starting. Let's see this just for a moment. That's a
We
debug.
are
Let me get it.
we're running
Yeah,
low on time, so I don't want to slow down too much on this. But just FYI.
yeah. See this here when you do this Docker Compose, and it gives the file name, it gives the Docker Compose override file, and it does two things. It does up and it does down. So when you're saying up, so that means it reads this Docker Compose file, and all it goes and creates all these containers, and that's when it knows the what all the containers it is creating, and is there any dependency between the container and a container. Okay, so that being
Swamy,
said,
if you
let's
go
see.
back to that
Yeah,
output again, you'll also see that part of the Docker Compose then, the next step is that it creates its network using the local driver. So the
here.
default driver, yeah. So there's a network
Yeah.
creation piece there. Now, is it in that network creation piece, the bit you're on about, Robbie, where there's like a local DNS equivalent that maps the IP of the two containers so that it can translate to each other?
Yeah, I'm honestly not clear on where it's doing it. I'm just noting
Yeah.
the way that this behaves is like a system. So it's either doing it there or on the next step on the volume, because it could actually set it in the etc host.
Yeah.
You know,
Yeah.
you
Yeah.
could do it in a different way. One of those two.
I've got a feeling from the knowledge that I have on Docker
Here,
that it is something in
It's
with the network piece as well. You know?
network. Yes, right.
very good. Thank you.
That's the one which it does. I think when we get into this guy um, here, we can see that real quick here. Um, if you go and oh yeah, I think we can see this here in the containers. Can see this real quick. How does the Okay, see this 172.19. So it didn't start with 17, and that's where, as Jonny pointed it out, so it's creating its own networking. You see that 172.19. So when we flip it back, so when I create it, let me flip it back to this one. Set as where's my startup project? Yeah, and I do a set as startup project. And if I go and execute this as part of this uh, kestrel,
So you're going to
and
get a
now
new one, and it will be a new subnet mask.
exactly. So the IPs are entirely different, because when Docker Compose comes into the picture, as Jonny pointed it out, it is taking over the creation of this networking tool. It's taking over the creation of networking tool, and I just want to quickly see that. Let's do a try it out. I
Are
mean,
you on
it
the
might.
local host? Yeah, I guess so.
Yeah, it is coming in here. Now if we go and check the containers over here, let's come back to this one, and let me quickly come back to this and go here and remove that. Now we should be able to see this products API. Let me start this products API and come back into this. Let me refresh real quick and select this and go to the details. And we should see that this network itself, the gateway itself is different, 172.17. But whereas these two containers, which is being created, is in 172.19. So Docker Compose is taking care of that networking stuff. Cool. So, other quick thing which we want to discuss is, let's take real quick 1 minute to showcase all these things. I think there's some celebration.
Yeah.
Yeah, busting the firecracker. So we have a lot of the scripts here. So let me run this scripts. And this one. Where am I? I'm in here, and do I see the scripts folder? What is that? Yeah, that scripts folder is there. So let me do a clear scripts, and I want to show this piece. So let's see that. So the thing is that here right now we have this Docker, the whatever the code we have. So we are tagging it, and we are pushing that to our Docker hub. So hub.docker.com. Let me quickly go into this, and we'll take real quick 2 minutes.
All right.
We
I
might.
have one other thing I want to wrap up with after you're done, just as I go back to the very beginning. I'm just letting you know.
Yep. So if you see that whatever the image which we pushed it to the Docker hub, the same image, the products, eShop products, was 2 months ago. So now that we are pushing it, so what it is doing is it is creating the latest image, and it will go ahead and push it. Now it's creating the container, and it is bundling up, and it is tagging that image, and it is pushing. Now if you see that, it goes and it pushes this to the Docker hub. So the repository, to my repository, it goes and it pushes. The first thing is it builds it, Docker build, the file name, the Docker file name, and we are tagging the repository. We are doing two different taggings. And the next thing what we are doing is Docker push into the repository with the tag as well as with the version. The version we are using the git log so that it creates a unique ID based on every check-in. So it sees that some of the layers, because the code did not change, some of the layers it is already existing, some of the layers which is different, so it goes and it pushes. So now if I come back to my Docker Hub and do a quick refresh into this, the tags, and switch back to this one. Now you see this few seconds ago. The 2 months was the previous push, and now this is the latest push. That's one thing. And this scripts folder has got wealth of knowledge. So if you go and see this, the other thing is we can go ahead and create. We can go ahead and create this resource and deploy it to, yeah,
Azure resource. Yeah.
Azure resource. So let's come into real quick and see this, execute this scripts right now.
So this is going to put the whole compose, like all of the pieces together in one Docker image up there.
Yeah, the previous one, the B1 script. The B1
Yeah.
script containerizes, it takes this entire image, tags it, and pushes to the Docker Hub. Now, what we are doing is we are creating, uh, using the same image, whatever we pushed it here, with the same image. Now we are creating a container uh, container instance, Azure container instance. We are creating an Azure container instance and deploying these binaries, the products service, to that Azure container instance. Now, if I quickly come back to this one, AZ resource group, this is where it goes and deploys that. So we can come and check this example dot bash rc, and AZ resource group is this one. So I can quickly come back over here and do a refresh. Are you guys seeing uh, anything here? You're not seeing my subscription ID?
That's
Yeah, it's
right. It's
blurred
blurred
out.
out.
You've got it blurred out.
Oh, no, I didn't do that. That's one of
That's pretty
the
good.
Chrome extension. Chrome
Yeah.
extension.
Yeah.
So AZ mask, that masks this one. Now see this, whatever we are executing this command, that command goes and creates this products here as part of the Azure container instance. Now we are showing multiple deployments. We showed one of the deployment we showed is how do you execute in Kestrel, how do you execute it in Docker, how do you execute in Docker Compose. Now we are showing that how do you execute inside this Azure container instance. So that's the one of the big stuff now coming up. In the next 2 minutes, if you see that, it will be pretty interesting. Now, after that, what we are doing is the same scripts folder. If you go, I execute the B3 command. When I do the B3 command, what we are doing is we are again going back to the same Docker Hub image. We are bringing this image, and now we go and create a app service. We create an app service, and we'll deploy our binaries into that app service. Let's see that in next 1 minute. We'll see that in the next 1 minute that it is creating the app service and it deploys this binaries. We'll go and see that. So in the meanwhile, I will quickly copy this to see are we able to get this slash API slash v1 slash products. Okay, there you go. So we were able to deploy this products into the Azure container instance, the image which is coming in from here. We'll see that. The next 3 minutes is pretty interesting. We are going to change everything. Okay, that's one thing. And
There it is.
okay, it is deploying. I think the B2 script, B3 script it deployed. Okay, B3 script it deployed. The next thing is what we are doing is the B4 script. The B4 script is we are deploying it into the Kubernetes. Now, right now we are not
Hey,
going to discuss.
Swamy, can you just stop for a second and just as a refresher for people who haven't seen these scripts, who haven't are not as familiar with it? There's a rationality to this naming convention, right? Like the A is one deployment type, the B is one deployment type, the C is one deployment type, and then the numbers are the different steps, right?
Exactly. Thanks for stopping me, Robbie. I really appreciate it. Really, thank you so much. So the first one is A1 script. It's for anyone who doesn't have this Visual Studio Code or the Visual Studio. Still, if they have a Linux system and they have .NET 6, they can go ahead and execute this A1, so that will build, and you can see the scripts running in. Like if I go and execute this scripts in execute an A1 script here. Now, so what it does is it compiles and it executes it locally. So that's one thing. I'm just stopping it just for the in the interest of time. And B2 series is what the first one. B1 is where you take the local binaries, compile it, create the image, tag it, and push it to the Docker hub. And B2 script is you take the Docker image from the Docker hub, drop it into the Azure container instance. The B3 is you take the same Docker image from the Docker hub and deploy it into the app service. That is multi-container apps. So you see that the products API in the web. So that means this YAML template. This we are saying that again. You see the same things. It's marrying whatever we saw in the Docker Compose. It's a similar script where we are marrying two containers. Okay. And now coming back to the B4 script. B4 script, what we are doing is we are talking to the AKS. Now the now the key thing is I don't need to have multiple things to test it. I don't need to go through the browser. All I can do is I have a uh, one single Postman scripts where I'm saying that, hey, go and get me the content from ACI. This is coming from the ACI. When you mouse over on this, you see this HTTP ACI products API. Now, if I want it from the app service Kubernetes, app service, multi-container app service. I go and hit it. Now I'm getting it from here. You do a mouse over on this. You see it? That is app service. Now when I switch it to the local, what is the port? You observe that the port number is 27265. That means that is expecting the application should be running on Kestrel. So if it is running on Docker, it will have a different port. If it is running on a Docker Compose, it will have a different port. But if it is running on the Kestrel, it is 7265. So now, if I come in here and I click on this, it is getting the content from the local. That means the port number. Now you see this, I have one script or one set of Postman collection. Now I'm doing it testing in n different environments. One is local, one is in Azure container instance, one is in the app service. I'll take real 1 minute and we can close this. We planned it to showcase in the Kubernetes also. Looks like we are running short of time, but I just want to show one simple thing here. In the deployment center, we'll go and check this deployment center. That is deploying through the YAML template. Whatever the YAML template which we have seen as part of this source code when we're deploying this, it is using this YAML template. Now we can go and check this real quick. See that? That's where it is there. And also, if someone wants to check that logs, if you go and check this logs over here, you'll get the logs. But the credentials are pretty much in a secret mode. That means if I come in into the containers, if someone wants to validate what is the properties, they will not be able to see my connection string because we saved it as the secrets. So secure environment variables. That means this connection string will be masked. No one will be able to see that. So we have built in some of the security things into this, but I think we are 5 minutes late. We will
Okay.
we will continue in the next session.
Yeah, I just want
Yeah.
to touch base on something you alluded to that you would have liked to have gotten to express, but you didn't get the opportunity to in light of time. You were talking about using Kubernetes. And so that's the next step that we're going to look at is instead of using Docker Compose, which is a simple pattern to follow, you can use kind of a more industrial grade approach, or sometimes it's considered that way with Kubernetes. I was wondering if you could just talk about what just really quickly, what do you think what's a benefit that might tempt somebody to move forward, or like why what was interesting to you, anything like that about Kubernetes, the reason why you wanted to go to that next.
Okay, so the big time thing in the Kubernetes is like there are a lot of things which will take multiple sessions, maybe 20-30 hours we can speak about the Kubernetes. So the first of the things is the architecture and features which Kubernetes supports. One of the things which I really like is the replica set. Let's assume that the product's API itself is future speaker. So 15-20 years down the line, this guy will speak and I will retire. Okay. Okay. So jokes apart. So what happens is the replica set. We have a product CPI. They have two instances. Now we said that the replica set is two, and you manually go and delete one of this container, and the Kubernetes immediately spins up the another container, and the entire container management. It has got a secrets and a lot of other things. Like you can see that each of this container it should have only so much of resources, like 50 MB of space or RAM or CPU, how many CPUs you should use or how many RAM you should use, everything like that one. And also the deployment, like we will few episodes down the line we'll have everything whatever we are doing it through the scripts. This was the step one. Step two is we'll move to the GitHub actions, and all the infrastructure whatever we created through the scripts, it gets created through the Terraform. So we'll have the CI CD, continuous integration, continuous deployment. We might go to the continuous delivery. The only difference between, I might be confused between the continuous deployment and the continuous delivery is when you do the one of this term is when you go and deploy it, there might be a manual process like you deploy to the dev environment. In another term, whether it is a deployment or delivery, I'm a little confused. But in other term, what happens is you go and deploy it in one of the environment. You run automated test cases. Once you know that this is working, you push it to the next environment. Test. Again, you execute it, all the test cases, everything 100% pass, push it to the pre-prod, then to prod. So I think that's continuous delivery, if I'm not wrong. I might be confused.
No,
But
that's fine. That's about right. So like the CI is the testing part, and the CD, the deployment, is the deployment part. It's where you actually allocate the resource or put the artifact on the resource and turn on the resource. But you usually do those things together, right? Like an agile process is usually we're gonna try and set it up so that we can get our deployment to go from to automate as much as possible so that we can streamline. We can do weekly releases under production if we want, and things of that
right,
nature.
right. So I'll show it in the next episode. There are three terms. CI in CD there is continuous deployment and continuous delivery. So the continuous CI, continuous integration, is the one where you have a gated build which validates the binaries are in a compilable state, does a static analysis, and it might do a software composition. And then once the approvers approves that and the code gets merged to the branch, we do a CI, continuous integration, creates the artifacts, drop it to the drop location, and the continuous deployment takes this and deploy it to one particular location. And the continuous delivery is execute the test case and push it to the next environment
So
automatically.
I think it's even a little bit bigger. It may even be a little bit bigger than that, where product gets involved, and you actually go through the process of saying, here is a feature that we're going to be, releasing, and we're just going to take this straight up, and then, once it's ready to show in any way, take it to production, and then modify it while it's in production, and get it up to spec while it's in production. Right? It's an
Right.
agile process.
Serious process. That's serious process. So what's coming in the fifth session of this is pretty much we'll introduce the record instead of using the class. We'll use the record data type. and then we'll have a unified model of the response. Like how do we use it in our Node.js projects, where you have success and some message, and then the data inside the data you have different content. So something like that, and little bit of other features will come in, but we'll see in next 15 days. Anything else you want to cover, Robbie?
No, no, I can't wait. The Kubernetes part is something that I have definite interest in. I want to learn. I can't wait for you guys to show me this.
Let's do it. Let's hit the road next episode. At least the fundamentals of Kubernetes, or directly let's taste that Kubernetes, then we'll come back to the fundamentals.
Awesome stuff, both. I mean, that was great. Thanks, Robbie, Swamy, for taking us through all of that. It's been a great session. So yeah, I think we're looking at the 1st of July. Is 2 weeks,
Yeah.
2 weeks time. So yeah, let's hook back up then. So everybody that's watching, thanks very much for joining us. We'll catch you all in about 2 weeks time. Cheers,
right,
guys.
guys.
See you soon.
Good night, folks.